why the entropy of the universe is going on increasing over time. Yes, this is the topic of discussion of today's video. You know, the concept of entropy came from second law of thermodynamics. And according to the definition of entropy, entropy is a measure of disorder of a system, or entropy is a measure of randomness of a system, or entropy is a measure of the number of configurations of microstates of a system. So, if you follow carefully, if you observe carefully the universe, then you will find that day by day, means with time, the disorder, the amount of disorder is going on increasing. In the beginning of the universe, that is at the time of Big Bang, there was no existence of force, there was no existence of energy. Everything came out of nothing. So since force was not there at the time of Big Bang, energy was not there at the time of Big Bang, so the entropy of the universe at that time was zero. And after that, over time, entropy was going on increasing, and still today this is increasing over time. Yes, according to the second law of thermodynamics, entropy of any isolated system will always increase over time. So if you consider our universe to be an isolated one, then in that case, using that principle of second law of thermodynamics, we can say that entropy of the universe is going on increasing. If you can consider the universe to be an isolated system, only in that case. Yes, locally there may be decrease in entropy. Locally, such as if you consider a refrigerator, then the cold chamber of the refrigerator, the entropy of the cold chamber of the refrigerator decreases. But if you isolate the refrigerator from its surroundings, then you will observe that your calculation will result in increase in entropy of the refrigerator. Locally there may be decrease. Disorder is increasing. Okay. Then, if you consider the creatures, if you consider the planets, if you consider the human beings, are they a result of disorder or are they a result of order? Yes, answer to this question is they are not the result of disorder of the system or of the molecules or of the atoms. So, everything means living organisms. I am talking about living organisms. If you consider only those things, okay, locally there is decrease of disorder, and that's why the formation of those things were possible. But if you isolate a human body or any creature or any plant, then isolate means isolate from its surroundings. Means there will be no interaction of mass to or from the surroundings. Sorry. There will be no interaction of energy. There will be no interaction of work. In the absence of interaction of mass, interaction of energy, interaction of work, the system is said to be existing in isolated condition. And if you can do this, then you will observe that entropy of the living organisms also increases over time. And if you follow in statistical mechanics, you will find an equation known as Boltzmann's equation, which is used to calculate the entropy of the universe, which is given by S, that is entropy, is equal to K, which is called Boltzmann constant, into logarithm of omega, capital Omega. Here omega is the measure of disorder. K is constant. So we can see that here logarithm means natural logarithm, okay. So entropy is proportional to natural logarithm of disorder of the universe. Or if you consider any system of your choice, then for that system entropy is proportional to the logarithm of the number of configurations of the microstates of that system. Okay, anyway, my aim was to discuss in this video why the entropy of the universe increases over time. So our observation says that the universe is going toward a state of maximum disorder. That's why the universe is going toward a state of maximum entropy. Okay, so this was all about today's discussion. Thank you. Thank you for watching this video.